So arithmetic series. So the first term is given by as follows. So A, the common difference is found by D, and then any term in the series can be found by the following. So the first term, n minus 1, so where n is the number of terms in the series, and then D is the common difference. So again, just write all these down, pause it, write them down. So examples. So for the first term, literally it's just given as A, as it says here, first term. And then the second term is A plus D. And then the third term, so this would be n minus 1 here. So we've gone 3 minus 1, which is 2, and that's why you get 2D. And then the fourth term again is just A plus 3D. Yep, so they're the nth terms. Another part of the arithmetic series is known as sum of. So the sum of something, so it may say the sum of when n is 10, for example, and there's 10 numbers in the series, and then it's given by the following formula. So again, just remember these. So remember this formula, and then this one. So we go n over 2, 2a plus n minus 1, d. So example number 1. So we can just go through this together. Pause the video anytime if you need to. So we have the first 15 terms of an arithmetic series is 7 times the fifth term. So let's write that down. So the first 15 terms, so 15th term would be A plus 14D, and this is equal to 7 times the fifth term, so A plus 4D. Yeah? So that's the fifth term, and that's the 15th term. And then the second part says the sum of the first 11 terms is 88. So the sum of, remember, is S equals n over 2, 2a plus n minus 1 d. So subbing that in, so Sn, sorry. So n is 11, so S of 11 is equal to 11 divided by 2, 2a, we don't know a, because that's what we're trying to find. And then plus the 11th term, so this would be 10, so 11 minus 1 is 10, obviously, and then d. And this is equal to 88. Cool. So we have two equations here. We have equation number 1 and equation number 2. And for part A, it asks us to find the first term, which is A, and the common difference of the arithmetic series. So using number 1, equation number 1, we know that A plus 14D is equal to 7A plus 28D. So if we rearrange this now, and we take everything over here, so we got 7A minus A, which is 6A, and then we got 14D, so 28 minus 14 would just be plus 14D, which is equal to 0. So that would be our equation number 1. And then equation number 2, so doing equation number 2 again, we got, so we got this 11 over 2a plus 10d is equal to 88. So I'm going to take the 2 inside now. So 2 divided by 2 would just be 1, and then 2 divided by 10 is 5, and then multiply both by 11. So I got 11 times 1, which is just 11a, and then 2 divided by 10 is 5, plus 11, so it's 55d, and that is equal to 88. And that is equation number 2. So next we're going to look to solve. So solve. So using equation 2, I'm going to get it so in the form that a equals something. So I got 11a is equal to 88 minus 55d. Taking it over here. So a is equal to 8 minus 5d. Sub that into number 1. So I got 6 bracket 8 minus 5d plus 14d. 14d is equal to 0. So I got 6 times 8, which is 48, minus 6 times 5 is 30d, plus 14d is equal to 0. So then we got 48 minus 16d equals 0. So 48 equals minus 16d. D is equal to 48 over 16, which is equal to 3. Which is equal to 3. So then we're going to sub back into 2 to get A. So A is equal to 8 minus 5 bracket 3. So A is equal to 8 minus 15. A is equal to minus 7. And that's your answer. So we got D is equal to 3 and A is equal to minus 7. So part B, we're given the nth term of the series is 143. Find the value of n. So from A, we know that A is equal to minus 7 and D is equal to 3. So the nth term is just given by the following form again, A plus n minus 1 D. So we know A is equal to minus 7, and we don't know n, so we got n minus 1 in brackets. We know D is equal to 3, and this is equal to 143. So rearranging, so we take the 7 over there. So we got n minus, well, we got 3 minus 3, open the bracket out, is equal to 150, so plus 7 to each side. Then we can take away, so 3n is equal to 150 plus that, so we 153. Then n is equal to 153 divided by 3, which n is equal to 51. And that's part B done. So this is a question from paper 2018. So again, let's see what we got. So we got the first 7 numbers of an arithmetic progression is such that the last term is 71, and then the sum of all these numbers is 329. So what we know from this, we know n is equal to 7. We know the last term of the series, so which would be A plus 6D, so that'd be the 7th term, yeah? Which is equal to 71. And then we can label this equation number 1. And then number 2, so we know the sum, so S of 7, which is equal to 7 over 2, 2A plus n minus 1, we know n is 7, so it'll be 6D, and that is equal to 329. So this is equation number 2. So solving using equation number 1, we know A is equal to 71 minus 6D. So you subbing that in to equation 2. We know, so dividing the 7 by the 2, so we got the 7A, because the 2's cancel, so they would cancel, and then this would become 3. So we got 7A plus 21D, which is equal to 329. So A is equal to this, so 7 bracket 71 minus 6D plus 21D is equal to 329. Don't know why I done the 9 first. So now I'm going to look to divide through by 7. So I remember I got to do a whole equation, so this would just be 71 minus 6D, and then 21 divided by 7, which would be plus 3D, is equal to 329 divided by 7 is 47. And then we got to group the D's and take it over the other side, or bring it over here. So we got 3D is equal to, we got 71 minus 47, which would be 24. And D is equal to 24 divided by 3, which is 8. So we can sub this back into this here to get A. So sub back into 1. So A is equal to 71 minus 6 bracket 8, which would just be 48. So 71 minus 6 times 8, 48. So A is equal to 23.